Good day, everyone out there. Thank you very much for attending. This is Matt Hoyt. Today we're going to be going over Creo's interactive surface design modeling extension along with the advanced assembly extension. So we'd like to thank you all for attending. So I'm from MRC, Maintenance Reseller Corporation. We've been a PTC reseller now for about 11 years. We started off handling support renewals across North America on behalf of PTC. Grew at that very quickly and got signed on as a full reseller. We're a little unique. We're an inside sales situation, so anything you need, we work mostly via internet and phone. So if you need additional webcasts, information, quotes, we handle everything all online. But for you guys, that means we're one central location. Anything you need implemented or help with, we can usually turn around within 24 hours. A little bit about myself. I have a background in mechanical engineering, which led me here to working with PTC and MRC. I've been working for MRC now for 5 years. And like I mentioned, we'll handle sales and renewals across all the product lines of PTC. Today, we also have been very lucky to have Andrew Leedy with us. He also has a background in mechanical engineering. He's out of Greensburg, Pennsylvania. He's been working with PTC for a while now, and he mostly focused on Creo as well as ThingsWorks. So that being said, again, today we're going to start off by going over ISDX, the surface designing extension for Creo, and then we'll follow that up with advanced assembly. So Andrew, I'd like to pass this over to you.
Thank you, Matt. As you said, my name is Andrew Leedy. I'm an application engineer here working at PTC, and I will be running through the very quick demonstration of ISDX and AAX, and hopefully talk to you through the value points of both of those extensions. So before I get into the actual capabilities of ISDX, I just want to take a step back and talk about some of the challenges that we're hearing from our customers that you might be having as well if you're looking into a solution like ISDX. The main and the simplest thing I can say about it is that surfacing is pretty hard to do within CAD. It's easy to extrude and revolve, but a more complex surface and feature, those can be pretty difficult to manage. There's also problems with concept design happening outside of engineering. There is sometimes a disconnect between our concept design and our final design. How do I go from that concept to my parametric modeling in a flawless manner? And if we're working in Creo, sometimes the concept design happens outside of Creo. There's a lot of really good tools out there. Rhino is one of them, some of those other tools that do concept design, but it's a little bit more disconnected from the main engineering role. If I send over a concept design to an engineer, what's he going to have to do? Is he going to have to start over, redesign based off of the model that we give him, or how is he going to manage those difficulties? And all this matters because cosmetics do matter in our designs. We worry because looks really do matter, and we want our surfaces to look good and our parts to look good. So that's where we're coming from in terms of interactive surface design extension. It's an extension inside of Creo specifically for surfacing. It is an intuitive and flexible surfacing tool, so easy use. It's in Creo, not too different from any of the other Creo extensions in terms of the learning curve around it, but there's a lot of things that we can do with it. Basically, it combines freeform and technical surfacing in a single environment. I want to be able to do both of these, and I want to be able to switch back and forth to whatever is in whatever I want to use for that application. And it really allows users to develop compelling design variations pretty quickly. So see what works best and make some changes very fast. It allows us to design precise curves and surfaces to achieve those manufactured products that we're looking for, because it's not just enough to say that it looks good in CAD. I need to be able to build it, and there's some unique challenges around taking our CAD models into manufacturing, but that's another whole story. But the surfacing in Creo allows us to make sure that we minimize some of those challenges. And I also want to be able to confidently explore my design variants, and I want to be able to use my direct curve and surface edit capabilities to do this. So play with different things. Set certain areas to be designed parametrically or other areas to be freeform, and just go forward and see what will get my design out there quickest. And just create products that look better, sell better, and get to market faster. Now, who's this extension really for? It's for concept and industrial engineers, so anybody who is doing the early concept work of our products. And it's also for those engineers and designers, so people who are running Creo but just need a good cosmetic shape. So with that introduction to ISDX, I'd like to step into an actual demonstration and show you what this would look like. And we could start talking about what this would look like within Creo.
Andrew, I want to mention something. I think what you said is really important, because I run into this a lot selling the software, is that, yeah, it's great that it looks nice in the CAD, but we want to make sure it's actually buildable and not just, hey, we've got this fantastic design, but there's no way in today's reality to be able to put it out. So I think that's really key.
Exactly. Thanks, Matt. So here we are within Creo, and we're just going to be working with a shaver here. So I have some of the basic components and the key components laid out, but I need a shell that's going to go around this. And to give me a starting point, I'm going to start with some artwork. So oftentimes in concept design, that's what we have. It's going to be a JPEG or a PNG image or some sort of sketch that somebody's done for me. And I want to use that as my starting point, and Creo lets me bring this in. So this is just going to be a 2D image overlay. Obviously, this isn't necessary, but it does give me something that I can start to design off of. Since it's just a 2D image, we want something that's going to go on my top view as well. So we can look at and design in 2 separate directions here and kind of build off my 3D image that way. So let's get into ISDX and see what we're actually talking about here. So up in the style, my ribbon, that's how we get to ISDX. And ISDX is all about just throwing in curves and then adding surfaces in between them. And there's a lot of different ways on how we can apply those. So here we're just going to start by placing in some simple basic curves that are just going to give me a general outline of that shell. And I can always go tweak these a little bit further. So once I have that basic framework, it's all about manipulating this. This can be a very hard control, so I want maybe this edge to be exactly normal to a plane or tangent, or I can just start to freely drag these around to place them in their, where they should be. And as we add in these curves, you can kind of make a note of that style tree over the left and see how these features exist there. It's a separate area from my model tree, but they can both coexist pretty good. We have a lot of ways to go further with this. So right here we're doing a curvature plot. This allows me to see where I might need to fine-tune the surface a little bit, make sure that I have a good continuous surface on the entire thing. I don't have any jagged edges that are going to give me problems when I go to manufacture this. I can also add in some additional control points on these curves to tweak them a little bit. Now we can do the same thing at the bottom, add in some constraints, tweak some points, just get me a little bit closer to that image that we started with. Again, that was not something that's mandatory to start from, but it is a good idea to have a general idea of what these curves are going to look like before we start. Now within ISDX, we also have the ability to go into an automatic 4-panel view. So this is something that's pretty popular within cosmetic design tools. It gives us the ability to have an ISO, a front view, a left view, all at the same time so I can design concurrently within all of them. I make a little tweak in one of the views and I have it drive in the other views as well so I can make sure that I'm really getting a good curve all the way around, being able to design in a true 3D space. I also make sure that I don't have any very glaring mistakes. Again, sometimes doing a 2D curve in a 3D space, things don't turn out exactly as you will, but with a 4-panel view, you really can't go wrong. You see how it's being driven in all the directions. You don't have to worry about causing any issues for yourself. Just lock yourself to a certain view perspective and then move back and forth between all of them. Now we can just finish up these curves on these ends. The 4-panel view really just helps with this, getting a back view as well as looking at the side there to make my initial curves. I don't have to rotate around my model to adjust them in any direction. I'm really kind of confident that I'm going to be able to do this on my first try as I go through and build these curves out. Now, once we've defined our curves, we can always go back in and modify those if need be. Maybe we just need to tweak it a little bit to make it so that the end constraints are a little bit better. But we have our general curves defined. I want to build my surfaces. So we just go through, hide these images. We don't need them anymore. And building our surfaces with ISDX is a simple matter of selecting the bounding curves we want and then selecting how we want the surface to interact at those endpoints. Do we want it to be normal? Do I want it to be curve continuous? What kind of curves am I looking for? And we have a pretty great control over how exactly we're going to be able to modify that. And again, notice the surfaces and curves all get placed within those, away from the rest of my models, trees, and the features. Don't have to worry about them. Now at this point, we're just throwing in some additional curves to drive our surface, and we can lock those curves to a certain plane very quickly. Again, utilizing that 4-panel view to build these curves out extremely quickly. We can mirror that general curve across the middle plane or whichever plane we set this up, just finish out a curve and have that also drive a surface in the other direction as well. Make sure that we have a good symmetric shape going on here. We can also control copy these central curves so we can have a little more control further back on our razor. It really doesn't matter what we're doing here. The point I want to make is that we can add in a bunch of extra curves after the fact to add in some additional control and change the inside of the shape a little bit. Okay, now we can just go through, finish out our surfaces. So I have those new curves. not only drive the curvature of the surface, but also drive the bottom of my shaver as well. So really make use of that work that we've put in. Again, go through, click on how we want those surfaces to interact. With Creo 4, we've added the ability to have G3 acceleration surfaces. So if you're looking for some really smooth curves, Creo is, every version is trying to put out more control over that, something that's really popular in stuff like automotive, body, things like that. We're continuing to push the boundaries there. We have a lot of different ways to use some analysis tools to inspect our surfaces. One of those analysis tools is a zebra plot, so something kind of popular within surfaces. Allows us to really investigate those transitions to see how smooth that surface really is, and if we need to go back and touch something up and add some changes. So a lot of different tools to help further that design and make improvements. So now we built the outer shell of the outer shape of my shell here. I can thicken this, solidify it, basically whatever I need to do to make this manufacturable. But I can be confident that we have some solid surfaces to start working from now. And the last thing I want to note about ISDX, and I think one of the most important things about Creo in general, is that if I make any kind of changes here, I want to ensure that my surface is going to update. So in this case, we have a datum plane driving that front of my razor, the angle of it. If I ever make a change like that, well, I've designed this with some good curves and some good surfaces, I can be confident that that change is going to be no problem, that I'm not going to have to worry about it. So basically, to wrap this up, if I can just skip to the end of my slide deck here, I just want to just touch on some of what we talked about in that demonstration right there. And the main thing I want to talk about here is that it's pretty easy to do. It's Creo. So it's not going outside of Creo to do this work. It's intuitive, easy to pick up, especially if we know the tool. But even if it is pretty easy to pick up and learn, we can go from some very simple designs to very complex designs. I can just design this cone, or I can design the entire cockpit of a helicopter. So I can go as far as I need to be with this. And it really does give us the additional option to make some pretty precise curves and surfaces within Creo. So get some highly engineered products. This is something that I can make that is going to be designed with some good engineering intent. Overall, we want to increase that engineering productivity and efficiency. So I want my designs to be easy to make, easy to modify, and this is especially true if I have a very complex part. I don't want to have to do a lot of redesign around that. Overall, just give us more options and more concepts. Try some new things, develop ideas further if we're able to do it quick. At the end of the day, get a product that looks good. This is the goal, and we want this to be done fast. So that is ISDX in a nutshell. Now, moving on, switching gears, I wanted to start talking about Advanced Assembly Extension. So Advanced Assembly Extension, completely different than ISDX. We call it AAX. It's all about designing in a collaborative environment. So it really enables organizations to improve the productivity of multiple designers who need to work concurrently on assemblies. And it does this by using something we like to call top-down design approach. So a top-down approach is essentially breaking the system down into subsystems to gain insight, or it's breaking down of a system into subsystems. So I can gain insight and be able to control all those subsystems pretty flawlessly and concurrently at one time. And I'll go into a little bit more about what I mean by that. Again, just stepping back, taking note of some of the challenges that we've heard from customers. 20 parts are pretty easy to assemble within CAD. I could build these in a lot of different ways. Probably only one engineer has to work on something like this, and I can put them together no problem. But what happens when we start getting a little bit larger? 200 parts, that's a bit tougher. A little more complex, more involved, more people involved, and you might have to reuse some parts. 20,000 is where it starts to get really complicated. A lot to keep track of. We have a whole team of engineers working on a model like this. So how do we handle this kind of design challenge? And part of the problem with dealing with large assemblies are that they are just so slow to achieve and so slow to work with. I don't want to have to be sitting around waiting for my model to come up. I also want to have to be sitting around waiting for a guy who's working on a completely different subsystem to finish so that I can start on my piece. And really, we just need those new tools and form methodology for a top-down design. Everyone needs to have the same plan in mind when we're working on the designs to ensure that when we put this thing all together, that it's going to work and we don't have to go through and make some radical design changes in any of those sub-assemblies. Because overall, changes can be very costly and time-consuming. So there will be changes, and they could be difficult to manage depending on how we start off that design. There are also some additional things that come in with this. It's hard to swap parts in and out, and Advanced Assembly can help tackle some of these problems. There's also need to protect intellectual property, so I need tools to only show part of an assembly. And overall, I need to do all of these different things a lot faster. So PDC solution to that is the Advanced Assembly Extension. So that's going to be a design tool for large and complex assemblies. As I was saying, it utilizes this idea of a top-down design approach. So part of this comes into part placement. So putting pieces together, not just one after another, but basing everything off of a top-level master design. So for instance, I have this geometry of this door. Well, there's multiple different pieces that we're going to have to build from this door. We have a door and a seal that are going to be made out of this. But they can utilize that same geometry to ensure that we're able to swap those out and pretty easily design around those. There's also this idea of mechanism design, where I might just want to be able to lay out lines so that this thing can, so that they are able to pivot and then use it to develop the actual mechanism. So kind of give myself a general path that this thing is going to take. Now, the main thing we're getting out of the Advanced Assembly Extension is this idea of a skeleton model. A skeleton model is a very special type of model. It basically just contains that key design location interface information. So it controls where things are going to go, how they're shaped, and everything is going to be built off of this. An example of one that's kind of like a lawnmower is over there on the right. I have a general idea of where those wheels are going to be, where my seat's going to be, where the feet are going to rest, some of the different components are going to be placed into that lower area. But this gives me a good starting place for all those different sub-assemblies to start being built. Now, this skeleton model is always going to be the first component of the model tree, and it's something that's usually controlled by the lead designer. And most importantly about all this is it does not show up in the bill of material or my mass property calculations. It is simply there to just help facilitate the top-level design. Now, switching gears a little bit, there are some additional tools within AAX that aren't entirely apparent right away. The main idea is around that skeleton model, but there are some other things kind of thrown in there. One of those is this reference control. So manage and limit component references. So when you have a large assembly, you want to be able to see which models are tied together. So this makes it so that I can track it down pretty easily, see what features are part of what assemblies, and just keep a good idea of how things are being put together. We also get this idea of inheritance models, which is one-way associativity. So if I make a modification to an inherited model, it does not change the original model. So it's pretty good for things like stripping things of any intellectual property or simplifying something for the process of simulation, stuff like that. We have two more here. One of those is interchange groups, so instant swapping of components, so swap lots of parts out at once. And we have the idea of this merge and cut out, so put parts together or cut shapes out of another. So with that in mind, I'd like to step into a demonstration of AAX and just follow what it would look like for a team of design engineers to be designing with something like this. So in a nutshell, AAX is going to enable people and organizations to improve the productivity of multiple designers, as I'd said, and they need to be able to work concurrently on this assembly. So in this example, we're going to be looking at the assembly of a train. So a very large assembly. Obviously, we don't have to be going this big to be using AAX, but it's a perfect use case because there are going to be multiple engineers working on different subsections of this train. So in cases like this and in many other cases, it just is not practical or efficient to be working with the entire assembly. But the design intent needs to be maintained at the assembly level because there are going to be multiple engineers that are going to be working and building off of the same thing. And this is also true for distributed teams. So even if I have a small team, they might not be talking to each other all the time. I want to make sure that the work I'm doing is going to get us there to the end without having to minimize rework. So using AAX, we can make sure that critical design information is going to be incorporated into my sub-assemblies. So in this case, we have a lead designer. They've identified what information each team is going to be required to effectively develop their own sub-assemblies. And it's done using this idea of publishing and copying geometry. So the lead designer is publishing the geometry that the other teams are going to need, and then he's going to go copy those into the individual sub-assemblies so that they can see that geometry. So things like the bottom of my train and the outside shell of my train, things that they're going to need to effectively go through and do things like build the outside structure or construct the windows or the doors to this train. They're going to need all that information. So we're going to go copy that information into the skeleton models of those individual sub-assemblies. Now in this example, we're looking at 4 different designers working on different parts of my train assembly. So the truck, the structure, the interior, the door, these are all being handled by different people concurrently. So each designer is able to work in parallel to further detail their individual sub-assemblies here. And what's really important is if the lead designer makes any changes of the design intent of the overall assembly, each sub-assembly is going to adapt and change as well. Additionally, we're looking at some critical design information being shared across multiple teams, so a designer really doesn't have to worry about how their changes are going to impact another team. So when individual team members are ready to begin sharing information on their individual subassemblies, so in this case we have working on the chair and the tables within the cabin, this can be easily accomplished. They can easily share this off. So it really allows us to support concurrent engineering. So he's going through, he's recognized that he needs to finish off some of the work on these chairs here. We have some seats. He's just doing this based off of, again, grabbing from this, the bottom of my train. So that was something I was shared off to him, and he's able to go through and finish all of his work here. In a non-concurrent approach, an engineer might just be starting right now. He might have just been handed this model from the guy who did the outside structure of this. But otherwise, he's able to complete all of his own work, check this in. All the individual teams are able to check their work in. So the guy finished the inside, another team finished off the door. We also had work done on the wheels and on the outside structure of my train. All this was done collaboratively. So that's the entire purpose of AX, just allow that effective collaboration for design teams that are going to be working concurrently on assemblies. So it really just helps us drive greater productivity in that product design process. Now, just to wrap up here, again, I just want to touch on the value points of what we had gone over. So the main goal we're trying to give with advanced assembly is improve my performance. So less time dealing with my models and more time just spent designing. So don't waste time dealing with the hassles of a large model. Be able to effectively design in a smaller approach. We also want to be able to make design changes with confidence. So I know that I can deal with the model no matter how large or complex it's going to get. With some of those extra tools, be able to enable efficient reuse and work collaboratively, whether that's going to be internal or external. So tie everything together with a proper top-level approach, because at the end of the day, we want better quality, customized products to our customers at a faster and less cost to our competition.
It's great, Andrew. Nice work. You know, and I want to point out, too, I think it's using the skeleton models. I think that's probably one of the biggest benefits that I hear most from our customers, being able to pull in the latest revision or the any last-minute changes to what they're basing their maybe sub-assembly off of. So I know it's a great tool that's come in very handy for a lot of our customers out there. Andrew, I did want to thank you for giving us some time today, coming out and helping us with this presentation. I'd also like to thank everyone who attended today, and we will have this available for replay.